Welcome back to our YouTube channel. We are looking at dimension analysis in physics, and the question we have with us is saying the velocity of a body is given by the equation v equal to b over t plus ct squared plus dt squared. Okay, find the dimensions for constants b, c, and d. So the way they are presented in this equation, they seem like they are numbers or other constants. Now, for them to instruct us to find their dimensions, it means that these b, c, and d are simply physical quantities. So to do that, we are going to look at the expression we have and see how we can work best. So we need to understand one principle where dimension analysis is concerned. The principle is that dimension analysis is algebraic. So thus, we know to say we can only add or subtract algebraic expressions which are the same. So which also holds for dimensional analysis. So for quantities to be added or subtracted, it means that they are the same. So that is to say, b over t is the same as ct squared, and it's also the same as dt squared. This is equal to our left hand side, which is v. Alright, so we solve for b, c, and d. Now, these three are all having t, which is time. And you know, say time has dimensions of a capital T. So we say, from this which we have, the ones we know in terms of dimensions is v and t. So, since everything is being equated to v, it means that we get this first part, we equate to v, second part to v, and the last part dt squared to v. So let's do that. So we have b over t equal to v. We are making b subject, so we cross multiply, and this gives us v t. Now let's do the mathematics. Now dimensionally b be written like this, and it will be equal to v, it is L t to the power negative 1 times t, like that. So this is equal to L t. Now negative 1 and 1 for t add, they give us a 0. And this therefore means that our b is nothing but L. And this is length. So we move on to the next one, which is ct squared, which is equals to v. So we divide both sides by t squared. And this therefore gives us c to be equals to v. We can still present this as t to the power negative 2. So dimensionally we obtain L t to the power negative 1 for v and t to the power negative 2 for what we have for time. So the dimensions for c will be L. Now t to the power negative 1 and t to the power negative 2 are multiplying, so we add the powers. Negative 1 plus negative 2 will give us negative 3. So this is our physical quantity. Okay, so now proceeding on to finding the one for d, we have that dt squared. Dt squared is equal to, so divide by t squared. We have our d to be equals to v t to the power negative 2. So now for the dimensions of d, we can observe that the expression is the same as for c. So which means that d is the same dimensionally as c, which is L t to the power negative 3. And this is how we go about it. Thank you very much.